Alright, so let's go through the 2022 A-level question on the washing machine. So we have this washing machine, right, showing the drum of a front-loading washing machine. Then the drum has a radius of 0.23 meter, spin at about 1,200 revolution per minute when drying clothes. So there are many small holes in the drum to let the water escape. So okay, for first part, AI, calculate the angular speed omega of the drum. Okay, so first omega, we know the formula, right? There are two formulas, 2 pi f or 2 pi divided by period. So which one should we use? Actually, you can use either or, but but if you look at the information given to us, right, especially the highlighted in blue one, so 1,200 revolution per minute. So it means that 1 minute got 1,200 revolution. So what about 1 second? So 1 second is about 20 revolution. You just simply divide by 60. So you divide by 60, you get about 20 revolution. And what does this thing actually mean? This thing actually means the frequency. Because if you remember the definition of frequency, frequency is the number of complete oscillation in 1 second or per unit time. So we can safely say that, oh, my frequency is about 20 hertz. So in this particular case, you simply just use omega equal to 2 pi f. So just use 2 pi times 20. So this will actually give you an answer of 126 radian per second. Okay, so that is quite simple. Okay, let's move on to part 2. Okay, part 2, we have this tower, right, having a mass of about 1.2 kg, considered to be a point mass at the edge of the drum. So the drum is spinning at a regular angular speed calculated in our first part. So calculate what is the force exerted by the drum on the tower, meaning that we are asked to determine the normal contact force when the tower is at the bottom of the drum. So you can see the very stark similarity, right, between 2021 A-level circular motion and the 2022 A-level circular motion. So for 2021, right, they actually asked us this, right. So for example, normal contact force, the ball is at the top of the loop. So obviously you can see that my normal contact force and weight is providing the centripetal force. So N plus weight. So this will actually give you centripetal force. What about at the bottom? What about at 2022? 2022, they ask us at the bottom. They test us the so-called point mass is at the bottom. So what will constitute the centripetal force? Very simple. It's just normal contact force minus away the weight. Meaning that at the bottom, right, the normal contact force must be greater than the weight in order to have some resultant force towards the center of the circle, which will provide the centripetal force. Okay, so how do we actually do this? Very simple. So first, you need to calculate the centripetal force. So mr omega square. So what you will get is about 4381 or 4382 like that, Newton. So that's the centripetal force. Okay, the next part will be normal contact force minus away the weight will give you the centripetal force. So you simply just use the centripetal force plus the weight. So this will give you a normal contact force of about 4390 Newton. Yeah, so round off to 3 SF. Okay, what about part 3? Part 3, part 3 I will not go through first because it's on simple harmonic motion. So for part B, okay, let's talk about the last part of the question. So explain in terms of the forces, right, why the water actually leave the drum through the holes when the machine is spinning. So means that the water is not undergoing any circular motion. Okay, let's see what is actually happening. So first part first, right? Okay, so imagine the water is right here. So this is the water molecule or water particles. So when the water particles is at the holes, okay, obviously there shouldn't be any normal contact force, because in order to have normal contact force, you must have some wall or solid, right, to provide the normal contact force. So since there's no normal contact force, the water molecules is not able to so-called provide for the centripetal force. So there's no centripetal force means you will not undergo circular motion. And of course, there's one more thing is that when the water actually reaches the holes, right, the water actually has a very high inertia. So for example, let's just say the water inertia is right here. So when you rotate, so there's some so-called speed or angular speed or tangential speed also can. So this water molecules will, when you reach this part, it will just travel up in this manner due to the fact that the water molecules has a tangential speed. So how do I explain the qualitative question? You simply just use, okay, first part, holes cannot provide the centripetal force for water to undergo circular motion. So you can also say that the centripetal force is provided by the normal contact force. So of course the water has inertia which cause them to leave the hose with in the direction of the direction of the tangential speed. That's it. So that is for part B.